Hello guys, so once again I welcome you all to my channel CSNet Lectures. So in this session we are going to discuss with planar graph examples. So what is a planar graph and how it is being identified. So all those things I have given you with theoretical examples in the last videos. So you can watch it and come over here friends, right? And I also request you to subscribe my channel, so it will be really a great motivation for us because we are working as a team, so that all will be getting benefited and motivated for putting more videos friends, right? So now we will go for example problem discussion. That is, if they have given you a graph, right, a normal graph, whether it is a directed or undirected graph, how to identify whether the given graph representation is a planar or a normal graph. So that we are going to discuss it with two examples, right? So when you just go on work out with many examples only friends, you will be feeling very easier to solve if any type of problem is being given. Okay, so that method we are going to follow because what I have said, smart work preparation is needed for the examination, right? So we can go for the discussion. So friends, this is the first graph representation that is being given. So now, what is the question being asked? Is the given graph a planar graph? So now, before going into this discussion, you must have to know what is a planar graph or an isomorphic graph, which is the other name for this. So what is a planar graph? So all these things, please see it in the previous video. So now I just want to tell you in short. So if the edges doesn't intersect, so it is called as a planar graph. If it intersects, it is not a planar graph, right? So now we are going to follow some methods to transform this into a planar graph. How can we do that? We are going to see it, right? So now by seeing this diagram itself, you can tell that it is not a planar graph because how many number of vertices are there? So how many number of vertices are there? So the vertices is 4. Okay, so how many number of edges are present in this graph? 1, 2, 3, 4, 5 and 6. So number of edges is 6. Right? So, and another thing is that these two edges are intersecting within each other. So, these two edges are intersecting within each other. So, we can surely tell it is not a planar graph. Now, suppose if I want to change this into a planar graph, how can I do? We can see it now, right? So, how can we do? See, for example, the condition for changing this into a planar graph is that edges should not intersect, that is the first condition, and you should not change or the position of the vertices. You should not change the presence of the vertices, right? Or you should not increase or decrease the number of vertices that is being present. So you should have to maintain the total number of vertices as 4 and maintain its positional representation also, right? You should not reduce even the edges. You should have to take care that they must not intersect. So that is the thing you should have to follow. So now I am going to change it. Let me see. So place this graph as it is. So A, B, C and D. Okay, so I am just placing it as it is. Now you join because these edges are not having any problem. So join as it is. Okay, these two edges are having the problem, right? So how can I change? So one edge I can keep as it is. Okay, so one edge I can keep it as it is. Another edge alone I can change its direction. So where let me take this edge B to D. How it has to start from B, it should have to start and it must have to reach to D. Instead of making it to move over this edge, I can join like this. Isn't it? So I can make this edge to come outside this graph. So this is also a valid graph, isn't it? So like this also I can draw. Okay. So now if you watch, these edges doesn't intersect within each other. So I can tell that this is a planar graph. Friends, is it easier, right? So this is the way you should have to change the given graph into a planar graph if they ask in question. Okay friends. this is another graph that is being given in order to find whether this is a planar or not. If not, change this into a planar graph. So like this only we are going to do as we did in the last question. Okay. So now tell me whether this is a planar or not. By seeing the diagram itself, you can tell that this is not a planar graph. How? Because the edges are all intersecting within each other. Okay, so the edges should not overlap. So that is the main point of planar graph, isn't it? So here how many number of vertices are present? 1, 2, 3, 4, 5, 6. So total number of vertices are 6. So the total number of edges is 6. So total number of edges are 6, right? So the total number of vertices are 6 and total number of edges are 6. So now we are going to take care while forming it into a planar graph that the edges doesn't intersect. So shall we do it? Right. Friends, it is really very easy. If you just go on practice, you can easily solve all these problems within a fraction of a second, friends. Right. So now, what is the condition? We should not change the layout of the vertices position and you should not reduce or increase the edges. That is the main condition, right? So now, this I can draw it as it is, isn't it? Because these edges doesn't intersect and maintain the vertex position. So E, this is F, this is A, sorry friends. So this is A, okay, so this is A and this is C and this is, sorry, because I must have to join these edges, isn't it? Only these I have joined, okay, just so that only I have erased this, we can use it in the later one, right? So now see, E, A and C we have joined with the respective edges. Now what I should have to take is E to F, F to C and E to D. E to F this one, D to A this one and F to C. If you see all these edges are intersecting, so this I should have to avoid. How can I do? So let me take one of the edge and I can connect it, isn't it? Because one edge I can draw because it will not intersect within each other. So let me draw this. So E to D, B. So this I have completed. So now the remaining two edges are F to C and D to A. How can I connect? Shall I draw like this, which I have used in the last problem, right? So that technique I can follow. So A to D I can take. So like this I can connect, isn't it? So A is here and D. See, this is the technique which I have discussed in the last problem. See, the same technique is being used up in all the problems. So all these techniques you can keep it in mind, okay? So A to D, this I have connected. So this over, this over. Now next is F to C. How can I join F to C? Just try it out and see. Is there any possibility? So F to C. If I join like this, it will intersect. Okay, so this is not a proper direction. Is there any other possibility? If I join like this also, F to C. Again, if I join like this also, we cannot able to do because here also it is intersecting, isn't it? So this is wrong. Is there any other possibility present? So in this graph, there is no direction for F to C. That is, there is no direction without intersection for F to C. We cannot able to draw because whichever possibility we take, it is not solving this rule. Okay, so I can tell that this graph is not a planar graph. Okay friends, so like this only you must have to determine, right? So this given graph is not a planar graph. Please make a note of it. So please make a note of whatever points that I am discussing. Okay, so while you are just referring it in future, it will be very easier for you. Okay friends, so in the next class, we will come with another super video. Okay, bye and thank you.